I'm here to talk about distributed systems and how we can shine a light on them to actually figure out how things are actually working when they're reaching production. So who am I to talk about this? So Aidan just did a quick intro, but so yeah, I'm SRE manager at Populo, formerly Newsweaver. And I've been working in Populo for almost 10 years now. I've had a number of different roles there, started as a junior developer and led a few teams, and now I'm responsible for reliability and essentially making sure that we give the tools to all our product teams to develop and release products in a reliable manner and quickly. So what does reliability stand for, essentially? So the best way to explain reliability is going through what Mikey Dickerson from Google designed at his work as an SRE in Google. And so what you can see here is a hierarchy of needs for service reliability. So it's the equivalent of kind of Maslow's hierarchy of needs for human beings. Essentially, tiers of requirements that, well, you have to fulfill one level of the pyramid before you can actually do the next in a proper manner. So the Maslow's hierarchy of needs starts with food and water. So you need food and water and rest before you can actually just say, well, now I'm interested in having a house and be safe, etc. And the next thing is friends and esteem and then fulfillment, all these things. So, and at the bottom of the pyramid for reliability is monitoring, which stands for the equivalent of basically food and water. So, and what's interesting there is that development and product are just very much at the top. So development and product are the fulfillment of reliability. They're not the base of the pyramid. So just to run quickly through this, so monitoring is see how things are working. It's see if they're not working, how do I get notified that they're not working? And if I get notified that they're not working, then I can actually properly do incident response. So now, how do I react to something not working? How do I kind of stop the bleeding? Do I turn off a feature? Do I add more resources? And only then, when I've mitigated the immediate effect of a problem, then I can go to the analysis of the root cause and figuring out the post-mortem do a post-mortem on these issues. And so it goes on. Once we're able to figure out causes, then we're able to see where things tend to go wrong, and then add testing, add procedures around these things. And so it goes on. Once we're able to do this, then we can plan better, because we say these areas are more tend to problems, we can plan better for them. And then only at that stage we can design for reliability, because now we have a full picture saying we know how things are working, we know the areas that tend to go wrong, we know how to plan, we know what are our concepts of saturation, of limits, etc. And then until we have everything done here, then we reach the product, which is the fulfillment of a reliable product. So I'm not going to talk about everything in here, because there's probably multiple talks for each of those layers. So I'm going to concentrate into the bottom one here, and probably even the base of this. So monitoring is composed of different things. There's like white box monitoring, black box monitoring, and visibility, alerting. So what I'm going to be talking about is visibility, which is mostly about white box monitoring. So analyzing exactly how things are working. And as I said before, the top of the pyramid is the development in the product, but everything else is actually nothing to do with coding, really. It's just about, okay, how are things running? And the reason for this is that reaching production is actually the beginning of everything. And this is flipping a philosophy that we've had for a long time, where we spend most of our time coding, and maybe up until maybe 10, 15 years ago, testing was kind of not really the big thing. Then TDD came, and everybody is pretty much in agreement, and I hope everybody is in a situation where they can say, well, if we don't test, then it's kind of an agreed outlier. But we're still spending most of our time developing, even if it's coding or coding tests, coding production code. But until an app or an application has reached production, like, we're just playing around. If you have a system that's not used by anybody, it is literally useless. So it's only at that stage that the real deal is when we get to production. It's not the finish line where you say, well, that's it, I'm done, I've put it onto production, move on to the next project. That's actually the beginning of things, because this is when we're actually confronting real users to this. And as we probably all know from experience, things will never run perfectly. like whatever effort we make into trying to make things perfect, this is never, like we can never plan for everything. And if you think that you have nothing going wrong in an application or a system that you're running, well, there's two cases: either nobody's using it, or you just don't know that something is going wrong. But there is definitely something. And as I said, there's only so much that we can think about, and there's only so much we can invest up front. Obviously, building quality in the software and in the applications that we're building is very important. But at some point in time, we're going to reach some diminishing returns into the effort that we're going to be putting in this. And instead, if we embrace the fact that, well, things will eventually go wrong, and then we can invest instead into, well, figuring out and giving ourselves the tools that will say, this is how I know things are going wrong. This is how I know I'm alerted that things are going wrong. And this is how I can just have the tools to go deeper in the analysis of proving theories of what's the source of the problem, how can I mitigate, and shifting that attitude from reducing or increasing the time between failures to reducing the time to recover from those failures instead. It's a balance, obviously. We don't want to say, well, we're going to code whatever, and when we have monitoring, then we can actually just, like, we don't have to do testing or whatever, but it is a balance. So all of this is actually pretty general. It's not really related only to distributed systems, but distributed systems bring another realm of problems in there, because maybe for a long time, and I think this is why we hear a lot about distributed systems and architectures like microservices and these things, like in the last few years now, is a lot of technology companies that started maybe 10, 15 years ago and that got successful and are still successful enough to have made it to this day, they're reaching scaling issues. Scaling in terms of people, scaling in terms of an application that has become too big to be maintained. And the solution that everybody is looking at is distributing it. And if we don't need to distribute it, then we shouldn't be. If you were there yesterday, Sean talked about that, saying that the startups will probably start with monoliths and they will actually just move to a distributed system if they need to. And that's what Martin Fowler said on like the first rule of distributed objects is don't distribute your objects. But eventually, if you need to get there, then you need to embrace the fact that now if we're distributing, we're also distributing the places where things might go wrong. We're going to have multiple systems, multiple servers, multiple services, potentially multiple databases running in the cloud, all talking to each other over different interfaces, most likely over the network, which is unreliable. So we're shifting, like we're trading off some things for now actually getting to say, well, no, we're going to have to tackle all these problems, and there's no longer one place to look for logs. There's no longer one place that we can actually SSH in and say, I'll just reboot the server. No, you have 1,000 machines on the cloud. How do you do this? These machines are dynamically scaling. I don't know where they are. So it needs to be automated. It needs to be systematic. So what I'm going to be talking about for roughly the next half hour is a few different patterns and a few different techniques that we can adopt to say, this is how we can shine a light on a different, on different things that we can do on our systems. The first thing is the kind of level 0 of monitoring is health checks, is be able to answer the question, are things running? Are things up? And a health check is basically answering the question, if I'm healthy, what does it mean? First level, is it up? Is it running? Is the server up? Is the service up? Second level is, well, I'm up, but can actually perform the stuff that I'm supposed to be doing. So we might have a service that's up, but that's relying on a database that isn't, or that's relying on some peer dependencies that aren't there. And finally, if the service is up and is capable of handling work, then is it capable of handling more work than it is now? So kind of saturation level, saying, okay, I'm up, I have dependencies, but I'm kind of running out of resources here, I'm busy, I'm already running jobs, I'm actually not as healthy, so just back off and just send me more things later on. Or it might be a signal for us to say, actually, we reached saturation, let's start more instances of this automatically. So once we've reached that, we've answered the question, are things running? But then comes a bigger question, is how well are things running? And for that, we can, just before getting to that, some strategies on how we can do these health checks. There's different levels, there's a range of different things that we can do. The most basic thing would be broadcasting something from a server or from a service, saying, just over network, general network broadcasting, hey, I'm service A or I'm server B or whatever, and I'm sending this message over just to broadcast it. The level up from that is using some form of service registry, potentially something like Zookeeper or etcd, and have the service kind of going on a heartbeat basis saying, well, I'm service A, I'm here. If you haven't heard from me in the next 10 seconds, then that means I'm gone. And just kind of continuously updating this. That has a little bit of trade-offs there because now the service or the server needs to have some knowledge of how to connect to that registry. So it's a bit of a step up, but then we add a dependency on potentially now another point of failure in our system. And if we flip that relationship, rather than pushing that information about the health status, we can actually just expose a health status from, let's say, a service or a server. Like typically, maybe an HTTP endpoint saying, well, I have a service that's on this IP, and I have an endpoint on /health that will respond with 200 if it's fine, and that will respond with 500 if it isn't. Maybe with a body saying, well, I'm not working, I can't accept any more work because my database is not up, or because this dependency from my dependency is not up. So this range, this range has different trade-offs in different places. If we do broadcast, then there's more of a responsibility on, well, how do I understand what's actually broadcasted? Registry is, well, more of a work on the service, and exposure means that we need to have some form of service discovery for actually figuring out where to go and look for these endpoints. So these are different strategies. Depending on the frameworks and the topology of your, of a cluster, you can adopt one or the other, or a combination of some. And well, typically Kubernetes, if you're familiar with it, will just use something like register and expose, a combination of both. So just back to where I was, we know how, once we have our health checks, we know that things are running. But how do we know how well things are running? And for that, we can use time series metrics. And that's a massive step up now from just knowing that things are running. Now we can actually have an insight of what is everything doing. And time series metrics are kind of tiered in kind of 3 different categories. There's first the most basic, most lower, the lowest level of metrics, which be system metrics. So typically something that an operations team might be responsible for. It could be network latency, CPU usage, memory usage, number of files open on a server, all that kind of stuff that we need to know in terms of, okay, how are things functioning at the lowest level. The level up from that is application metrics. So you have your service, and if your service, for example, is exposing some form of REST API, what's the error rate on that API? Or I'm getting a number of messages from a queue, what's the number of malformated messages that I'm receiving? These sorts of things where we can put more context in the middle there. So depending on the structure of the organization, this probably is kind of developer teams, product teams that will be responsible for this. Or I'd be more interested in these metrics anyway. And then the top level is business metrics, so customer facing, the impact that it has on the business, the impact that it has on the end user. Potentially sales, customer conversions, number of conversions on, let's say, a banner, or these sorts of things. And even though these might be separate and that at their core they might be owned by different teams, we still need to correlate them because there's always going to be a relationship between all of them. Let's say we have a problem where we're actually saying, well, actually we haven't had any sales in the last 15 minutes, and we can figure out, actually, yeah, that's because our error rate has gone up, because we're seeing that we can't communicate with one of our services, it's timing out, and we can actually figure out, actually, yeah, we have a higher network latency back in between our data centers, and this is what's causing the problem. Again, even though that might be a responsibility of different teams, we still need to have that correlation, and all these teams need to be able to say, well, here is kind of a common way and a common tool, and we can correlate that. We can't just go and say, well, the operations are going to use their own thing, and the business is going to use their own tool. If you want to correlate that, we need to have a central place to go and look at it. So that was the theory. So in practice, how does that work if we want to go and get these kind of metrics tracked? Typically, if we have number of servers, some appliances, so databases, cluster management infrastructure, all that kind of stuff, and services. So services might be microservices architecture, for example. All these types of points now will expose some metrics. Like either they will push them to a metrics collector, or they will actually expose them, and the metrics collector will go and grab them, depending on the monitoring tooling that you're using. And that collector is going to aggregate all these metrics, because it could be a lot of metrics from a lot of machines, a lot of services. It's going to store that in the time series database, and it's going to expose it through a query engine, which makes that now there's millions of metric points in those time series. We're going to be able to make sense of it, query it, and get some graphs out of it. And out of these graphs, we can create dashboards of meaningful stuff, distilling all those metrics that we're collecting from these systems. And stepping up from that, now we can use these queries and use these dashboards to say, well, actually, I'm interested when this line goes over this threshold, I want to know. I want to know if we haven't had any sales in the last hour because we don't expect that to happen. I want to know if my latency is going over a certain level because we don't expect that to happen. So again, this is still high level, and just to give you an example for what we use in Populo is Prometheus, and Prometheus is kind of ended up now being the leading open source tooling for monitoring in time series. So what it would look like with Prometheus is we still have our services, and Prometheus acts as the metrics collector and the query and the metrics query engine. And Prometheus will go and, using service discovery, figure out all the different servers, the appliances, the services that we're running, go and look at REST endpoints on /metrics, and say /metrics would be an exposed list of data for each of the servers. So for a server, it might be like, this is my CPU usage. For a service that's in JVM process, we might have garbage collection level information, as well as custom metrics like the number of sales that we've done, etc. And once we have Prometheus scraping all these things every few minutes, it's going to collect all that data and expose a query, expose kind of a query model for this, where we can plug in Grafana, to just kind of create all these kind of graphs and say, well, all of that information that, well, if I'm looking at a service on a one-to-one basis, it's going to be very hard to figure out anything. But now, by aggregating all these interesting metrics, can distill all that information, and in one place, I have one place to go and say, well, this is what I'm interested in. And on the alerting side, Prometheus provides also support for alert management and potentially saying, well, this query, let's say if I have no sales in the last hour, I want to actually send an alert, and that alert might be sent to Slack, it might be sent to PagerDuty or other alerting tools like these. So as I said, compared to the health checks, that's a massive step up. That's a massive step up in value, because now we actually have very much deep information and very much custom information, because we can instrument our code much better. We can add metrics for things that makes more sense for us. It's no longer just kind of a kind of black and white kind of, is it up or isn't, is it not up. But for that to work, the tooling that we want to, or that we need to have around the metrics, has to be very easy to use. Because if it's very convoluted to just go and add metrics, if it's just like, if it takes an hour to somebody to just go and create a dashboard, if the alerts are just kind of very hard to understand, it's not going to work. We need to be in a place where instrumenting the code, that means adding a metric, should just be one line of code. It should just be one line of code for us to say, I'm interested in this, add this line of code, and eventually I can see that in a dashboard. Same thing, we have a lot of metrics. So if we want to make sense of these metrics, it needs to be easy to query. Like, we can't just be making like some kind of SQL joins and all these kind of stuff. Like, the stuff that we want to look at is, I have these metrics, I have these services, I have these issues, give me a few operations that I can do on them, and then just give me a graph. That's all I want. And we want to query that not only to create dashboards, but also to say, now I have a problem, and I want to investigate, troubleshoot my problems. Using the metrics that I have, I can just go back in time for, let's say, the last hour and see, okay, what was the trends there? And it might not be something that we thought about, so it might not be something that's already in a dashboard. It might be something that we want to investigate. So once we have a number of queries, then we want to be able to create dashboards easily. Grafana is just kind of godsend really for this. It's just really, really powerful. It makes for beautiful graphs. It's kind of vanity a little bit sometimes, but it's something that you can be kind of proud of when you have these graphs and these dashboards. And then defining the rules as well, that's going to be key to take it to the next level, because monitoring is only good if you look at it. If you don't define rules, if you don't define alerts, then, well, it's kind of, if you didn't see it, it didn't happen. So, so this is a kind of, that tooling is something that needs to come as a whole. And if we want the adoption, then it's something that all the product teams need to be getting behind and just kind of have the education to know how to use a framework. So I'm not going to talk too much about alerting, because I said, like, this is probably a talk on its own, and probably multiple talks. But one thing that I would say around alerting is to shift the relationship between, let's say, causes and actually outcomes and symptoms. So alerting should be on something that's very important. It should be something that is user-facing. Or the users can't log in anymore, or we're not making any sales, or something that has an impact to the business. So it's more symptoms, because we don't be, like, as I suppose Dan North says, is you don't want to be woken up in the middle of the night because the printer is running out of toner. So it's kind of moving that scale and saying, well, what am I really interested in when I'm going to be woken up in the middle of the night by an alert? It needs to be actionable, it needs to be quick. And then I can use my dashboards for this. The dashboards will be richer. We're going to be able to say, diagnose issues and say, well, I have a guess that this problem is related to this. Can I just validate this or actually disprove it very quickly using the metrics? And it's kind of the first place to go to then validate these theories. And as things change, usually we can see that problems really occur when we make changes to production system, be it like new versions, new systems, a configuration change, a firewall change, or these kind of things. Most of the time, when something is broken, it's because we changed something. And by overlaying those changes on top of our graphs, for example, we can start correlating more. So not only we can say, well, I'm guessing this is this problem, but oh, hang on. We can see that this team pushed like firewall changes in there, and suddenly now we have more latency because now something is going somewhere else, or they had done like some maintenance work somewhere. That brings it again to the next level. So, for example, this graph is showing what they're doing in Etsy using StatsD. You can do a similar thing with Prometheus and Grafana. It's essential then to be able to now have efficient troubleshooting and not trying to guess and say, well, now I need to go to another system, I need to ask people what they've changed, etc. So now we know that something has gone wrong, for example, and we want to just go and say, well, I have some theories and I want to look at logs. And now that we've distributed the system, now the logs are just kind of all over the place. We can't, as I said before, we can't go and SSH into a box and say, okay, just tail that log and look for stack traces. It's not really maintainable anymore. You don't know where that box might be. There might be a lot of different ones. That box might actually be gone already. So we need to centralize all these logs. So tools like the Elk stack are very useful for this. We can aggregate all the logs into one place. But at the end of the day, aggregated logs is just more logs in one place. And if all those logs just all look very much differently, they're not consistent, there's no way to search for them in a consistent manner, it's still going to be a nightmare to figure out. So every service, every system should strive to get to some form of consistency on log. It's not always easy. Some systems don't make it necessarily that easy to just kind of say, I have a uniform log format, but we should try and say, everything should just annotate on what the services have some form of tracing on it, from some form of correlation IDs, saying this request came in and all throughout my system I can actually trace that request and I can say this happened, but this also happened in the same place and that was the same source, be it for requests for events. And then that leads to the next level after that is tracing. Those correlation IDs give us that full picture of the kind of, okay, now we can see where a request went. So if we take an example there of like a relatively simple system that's distributed and that has a number of different data stores backing it up, and the user is encountering an issue and just getting an error message saying, well, we could not complete your order or something like that. Out of this, we can actually figure out in our logs, okay, we figure out that there was an error and that error came from the service A, and we could find a trace that's like A1, B2, etc. And that trace now is going to be very useful for us because we can just apply that trace to our log search and say, well, just give me everything that happened that was related to this. And we can make our way through the entire system without guessing, actually, I think maybe E is down or the guys that are responsible for service E deployed a new change, but we don't really know if that's the problem. So we can search and say, the next stage is, okay, we found that there's a trace like that in the service F as well. And service F saying, well, we failed to complete the order because another service didn't work. And we can keep going that way, saying, well, service G said, well, I got that trace as well. but I'm just saying as an info that items are verified in stock. So we can say, well, actually, this is not this guy because it's actually fine. It hasn't done any errors. And as we can keep digging, using that same trace, so that same trace is going to be the same in all the logs, we can figure out, okay, the service age there saying, well, failed to save because I couldn't talk to Cassandra. So there we can actually pinpoint what's the issue, and there's no longer a thing of now strolling through number of lines of logs that might look differently, and we can say, actually, yeah, we found that an error is, we find that Cassandra is having timeouts, but we don't really know if that's related to that error. Now we can actually say, yeah, that's related because this is actually part of the same call. If you were not working in a distributed system, you would have that for free because that's just called stack traces. But you lose that power when you actually get to distributed systems. So tools like Zipkin make that very easily. So Zipkin or Open Tracing or Loki, and they give you things that look like this. Essentially, you can just take that trace, paste it in, and say, okay, this is what happened. I can see what services that went through. I can see what happened, even with timing. So not only we can diagnose some problems saying, well, there's an error that happened there, but we say, actually, this is slow. Where is it slow? We can figure out, okay, in this server, there was a select that was longer than everything else. And that has helped us a lot into diagnosing issues. Like this is something that we set up about 6 months, a year ago. And things that would have puzzled us for a very long time before, just by adding this tooling, it's just much more easier to understand, okay, this is where things are wrong. So just as a quick story, what we had recently is one of our peer dependencies, so in the team that I was working on, one of our dependencies were starting to get timeouts, to get errors from just retrieving data from one of our services. And we actually tracked down saying, well, if you're getting timeouts, well, that means we're just too slow to respond. So let's look at our response rate. And we could see from our graphs in Grafana saying, well, okay, this service is actually breaking its SLO, or service level objective, saying, well, now we're actually responding under 2 seconds, which is like drastically wrong. But then we figured out, okay, this is a service that also is invoking something else, and that dependency seems to be slow at times. But then looking at that dependency wasn't slow at all. So it was kind of a question, like, actually, yeah, there is something happening, but it doesn't seem to be in any of the services. It kind of seems to be in between them. So monitoring immediately kind of disproved the theory that one of the services was slow. It could have been a case of, well, you're slow to respond. That's because you're doing some computation, you're doing some operation or something like that. But it wasn't the case. There we could actually pinpoint this is happening between those two services. So what we could do with Zipkin is not only you can trace things between services, but you can also dig deeper into a service. You can instrument specific parts of code to say, I'm going to instrument all my database calls. I'm going to instrument other different things. And our theory was it was a DNS issue. It was a DNS lookup issue. And so we had tracking on very specifically the part of code in the JVM that does the DNS lookup. And out of this, we actually figured out there was a graph like this where there was just a little strip here and a very long strip of DNS lookup for what's actually should take microseconds. And that, according to that, then we were able to just go to our ops and say, okay, what has changed? And we're able to see, well, we've released kind of new versions of Kubernetes and the resolver configuration changed, and we were able to actually resolve that way. It was a very obscure issue, but we were able to just say, we can actually go to, let's say, our operations and say, look, we can tell you exactly. There's no guessing. There's no guessing as to what might be. This is exactly where this is happening. And because would be something very unlikely as well. You like DNS issues like that. It's like talking to your operations, be like, no, sure, DNS is fine. Like you must have a problem in your app. Instead of actually, no, we can say this is there. And it's comfort for us as well because we can just be comfortable about talking to them, saying, well, I think I've looked at everything, and I'm happy to say this is the problem. So, to kind of a few kind of general statements to kind of wrap up all these different techniques is ultimately what we want with visibility is to be able to operate our system properly. We want to be able to say, no, I have something in production. How can I have all the tools and all the techniques that gives me a way to have a fuller picture and ultimately just do a lot less guesswork? If we're flying blind, it's a lot harder to get a system that we can reason about. And then we can adopt some kind of, I suppose, scientific approach to solving problems. First of all, the monitoring just gives us evidence of an issue. It's not kind of a gut feeling saying, well, I think this is kind of slow, or it just feels like we're made less sales this month, or something like that. And then once we have the evidence of that problem, then we can make some theories, some hypotheses on, well, I think maybe it's A, B, or C. We'll have to explore these issues. And using our monitoring now, we can actually just go and say, well, actually prove or disprove. And disproving is actually one of the best uses of monitoring and of those graphs. Because unfortunately, most of the time, it's rarely kind of the one graph tells you, oh yeah, that's what's wrong, because there's so many things that can go wrong. But there's going to be that one graph that tells you, well, that theory that you're having, it can't be that, because this graph would be different. And just disproving something is just as important as proving the thing is right, because now we're kind of narrowing down on the problem. And finally, just correlating the issues that might happen with the recent changes is very powerful, because not only we can pinpoint the issues, but say, it's likely that these 2 or 3 things have changed prior to this. This is probably where we should be looking first. When we shine a light on the system for everything that might happen in it, then we can actually back up our theories and back up the work that we want to do much better. Again, it's about reducing guesswork, hunches, or gut feelings about saying, I think this area of the system is bad, I want to rewrite it. And like, we've all been like this, like, oh, I don't really like this piece of code, I'm just going to just refactor the whole lot because it's a mess and I know it's wrong. But for all we know, if we don't have anything to back this up, it's an anti-pattern, because, well, are we going to maybe just touch an area that was actually working fine? Is it going to make things more complicated? Is it potentially break something else? And worse, even now, if we make that change, there's actually no way to say, is this better or worse? Because we just don't even have a baseline. It's like optimizing bottlenecks. It's like if you optimize something that's not the bottleneck, then you're actually not changing anything. It might be maybe a year down the line, actually, yeah, this area now is the problem, but the visibility gives us the ability to say, pinpoint, say, yeah, we need to work on this because this is affecting us. And yeah, I know it's getting a little bit fluffy, but on top of getting the kind of production level confidence that we would have on, say, well, we want to have our system, we want it to be running. But on top of this, if we expose that visibility to everybody, if we expose that visibility to ourselves as a team, what we do is, like in all our team spaces in Popular, we have TVs. We have TVs with our Grafana dashboards that are rotating, and there's kind of nowhere to hide. It's nowhere to hide from, and it's not even about the business or saying, well, somebody's walking past and say, oh, your graph looks wrong, because, well, we're probably the best one to actually understand what the graph is about. But it's nowhere to hide from the team and from ourselves. It's like, you know, it's Monday morning, you're a little bit tired, you kind of have the Grafana open on your machine and say, oh, I saw something wrong, but sure, I hope nobody else saw it, because somebody else will deal with it later on. When it's out there, it's like, well, we can start asking questions saying, well, that looks wrong. Why didn't we get an alert about this? And maybe it was actually fine. And if it's not fine, then we can figure it out, add alerts and these things like that. Obviously, this needs a culture of safety, because if there's a culture of more kind of finger pointing and blame, then, well, nobody's going to have an incentive on adding metrics and showing them to everybody. So it kind of works. It works in pair, really. We can also distill that information to the other parts of the business, and even customers, if we want to. Like if you see, like AWS will have pretty extensive status pages on saying, well, this is all our regions, this is all our things, this is the status of the service. If it's not, then this is the state of where we are, there's a resolution and things like that. So I'm not talking about just kind of putting our Grafana dashboards about kind of deep response time and microservices level metrics, but we can distill that to maybe customer support, maybe our kind of key account managers to see, well, when somebody is calling, they can actually see, well, we're on it already. It's no longer the kind of black cloud of engineering. It's like, oh, I don't know what they're doing, and they keep breaking things. Now they can actually just say, well, when I'm looking at it, I'm looking at this dashboard, and it's like, we're on it. We don't have to wait for you to tell us that something is broken, or like, and this kind of builds that confidence and that trust from the stakeholders. So just to kind of finish, and kind of a quote that like I think is just basically showing the whole value of monitoring. That's from the SRE book from Google. So like if you haven't read that book, it's very, very, very valuable. It's basically a bunch of case studies from Google on like how they approach reliability and reliability at scale. And what it says is pretty much what I've been trying to hammer for the whole for the whole half an hour is, well, if you don't have monitoring, if you can't see what's happening, then you're actually blind to everything that your system is doing, and then you can't actually say that you would be reliable. So that's everything I have for today. I think there's a fair bit of time for questions, so happy to take anything if there's questions or comments.
Is the mic working? Yeah. So if you have any questions, I'll throw out the mic, and you just talk into this end of it. Okay, you ready?
Nice rugby throw. Okay, so when you have got everything coming into dashboards, how do you scale? How do you deal with the fact that you now have a huge amount more information, and things like false positives and whatever may send you down those paths? So basically, how do you scale this model?
Well, the amount of information, is it, or
essentially? You now have so much more metrics that you may have a situation, you come in the morning, something spiked, and you previously wouldn't have cared about it because you didn't know it was happening. Now you do care about it, and you start chasing it, and you have to go to a manager and justify that you're chasing it and so on. So how do you filter out false positives or things that just did happen but didn't really cause a problem?
Right. I think it's pretty much about prioritizing the events that might happen. And if we focus, like if we get our eye on the symptoms and what's actually pressing, is it like some imminent problem that might be happening on user-facing problems, or do we have clear symptoms? Can we see what's the effect? Who are the affected people? And this is where we get we can reduce the noise of alerting and the noise of actually just going on kind of wild chases of things that might actually not be problems. And this is where we can prioritize it by saying, well, first question is, who's affected? What's the impact? And like for us, it might not be as huge as it would be for companies like Google, where like potentially when they're making tens of thousands of dollars a second, downtime of a service, then it's counted by the second because it's going to be like adding up over time. So the quickest question is saying, well, I've seen a problem. Is there anybody affected? What's the remedy to do that very quickly? When it comes to maybe other more inconsistencies that we might notice on metrics, well, it's just more information. Obviously, we have to filter it out, saying, well, is this important? Is this a problem? Or just say, do we actually dismiss it and say, well, look, that's fine. We don't actually need to deal with this because in the big picture, this is not making a difference. So again, symptoms is the main thing to look for rather than just staring at graphs of low-level things, because if we stare at graphs of memory usage, like, there could be so many different causes on this. But at the end of the day, like, we have to trust that if it's kind of prioritizing the different levels and the different impacts.
Hey Pierre, so I have a question there. Like, it's more related to team management and all that sort of thing. So, like, when you build something like that, you want to react to problems and you want to analyze the data that you have to sort out that problem. But like, what about optimizations? Like, do you look at those logs like weekly, or I don't know? There is any way that you guys look at that and see where you can optimize and do a better job on what you are doing?
That's a good question. Well, I would say optimizing things just for the sake of optimizing things usually seems like kind of the wrong approach in a way. Like, I would say, just to reflect what I said in the previous thing, is like, if we optimize things that are not actually affecting customers, then obviously it's hard to argue to the business. It's hard to argue upwards, saying, well, actually, all the work that you've done last week to optimize that little bit, what value did it have to the company? So I would more use it as like troubleshooting, and just kind of, maybe it's not saying that we don't want to be looking at trends and looking at predicting that things might go wrong, but then we're actually predicting, saying, well, we're seeing that there's a problem. We're seeing that maybe our systems are getting slower, or response times are getting bigger. We can say, well, we can predict that this is going to be a problem now, or we can predict that we're going to be running out of disk, or we can predict these sorts of things, but it has to be targeted to where down the line this will have an impact. If we're just saying, well, we're going to reduce that API call from 100 milliseconds to 80 milliseconds just because we think it's better, then like we're picking the wrong battles, essentially. We won't be able to do everything, so let's do the things that have value rather than just kind of trying to find things to fix.
Cool. Any more questions? No? Oh, we've one here.
Hi. You mentioned about using the metrics to determine the impact to the customer. Is the business using those metrics for anything else, or are you using it as a mechanism just to respond to the business at the moment?
Well, that's I will be honest, that's the hard bit to do. It's just to figure out, okay, I have a service that does something, what's the value? So it's understanding, okay, how can I determine that is this service doing the right thing? Sometimes you can use different techniques. Sometimes maybe the metrics aren't necessarily the best way to get to this. This is where Blackbox monitoring comes into play a little bit more, where Blackbox monitoring is literally just look at the whole system and saying, I want to look at the symptoms. So it's things like synthetic monitoring of kind of looking at critical paths for users, just namely the simple ones can user login. And this is the sort of thing that we can look at by just kind of creating tests that just periodically just go and log in and tell us if it doesn't work. So it's about marrying a different few techniques. If a service or if an application has kind of very clear things that we can say, well, if this goes up or down, that gives us a clear information. But if it's something that's going to be too obscure, then that's very hard. And it's going to be different depending on every system and every application. And I would say getting right business metrics is something that, well, we can't come up as developers because it's going to be the product. It's going to be the entire company is going to have to tell us, say, well, this is what the value is. So working with user experience, working with product management, saying these are the important points. How can we implement metrics that convey that, I suppose, that figure or that behavior? So, yeah, it's something that needs to be thought through with other parts of the business, obviously.